All right, let's talk about angular and linear speed. All right, I want you to imagine that our whole class, or like 10 people, go outside of the football field and I'll hold hands, okay? And the person, let's see, it'll be me. Let's see, I'm at the very middle, okay? So I just stand still and I'm just holding the one person's hand. So we kind of have like a whole line of people and I'm standing in the middle and I just start turning around and we all rotate. It's like we're like one fixed line, right? So let's see, we have a little person at the end. Let's call that person Bob, okay? And I'm holding the hand of, let's say, Susie, okay? So we've got Susie close to me and Bob is way at the end, 10 people out, okay? And we hold hands and we start rotating around. I start rotating around. I'm standing in the same place, okay? I'm right at the 50-yard line or whatever. And I'm standing in the middle of the football field and I start slowly rotating around. And let's say it takes us like 10 or 30 seconds to rotate all the way around. Okay. So now tell me, I can't remember who's who. I guess I'm holding Susie's hand. Is Susie having to like run very fast or move very fast? No. Like it's taking us 30 seconds to just go around one time. She's moving pretty slow, actually. Now think about Bob way out at the end. Is he having to maybe he's like having to sprint, right? He's having to be moving really, really fast to keep the line straight, right? And somebody in the middle would be moving like half as fast. So that's the idea so there's two things happening here. There's angular speed. So suppose we all stay in a line and we rotate around and it takes us 30 seconds. Our angular speed is 2 pi radians per 30 seconds, right? It takes us 30 seconds, all of us, Susie, Bob, everyone, 30 seconds to make a full rotation. How about linear speed? Linear speed is how fast each person is having to move to keep it going, right? So the person at the very end, Bob, is having to book it, right? He's moving really fast. The person close in is moving very slowly, okay? So our angular speed is the same for everybody. Our linear speed is different depending on where you are in the circle, okay? So here's some definitions. As a point moves along a circle of radius r, its angular speed, omega, so this is a new letter, omega, it's like a curved W, okay, omega, is the angular rotation, theta, per unit time. So omega, our angular speed, is how far we go in radians divided by time. So in our little case, I said, I guess it took us 30 seconds to rotate around once. So it would be 2 pi divided by 30 seconds. Okay. The linear speed, v, of the point can be found as the distance traveled, which is arc length per unit time. Okay. So our arc length is s per unit time. So you can see why the arc length is much bigger for somebody with a bigger radius, right? Because s equals r theta. All right, when the angular speed is measured in radians per unit time, linear speed and angular speed are related by this. Linear speed equals r, the radius, times the angular speed. Okay. So these are all good. Honestly, these are three equations that it is helpful to just know, okay? Omega is, and this one you can kind of think of, it makes sense. The angular speed is the radians divided by time. Linear speed is your arc length divided by time. And the way they relate is V equals R times omega. All right, so let's do some examples where they ask us about this. All right, we've got a water wheel here, and it completes one rotation every 5 seconds. Find the angular speed in radians per second. All right, good news. This is as easy as you think it is. Okay, the angular speed is just rotation or angle per unit time. So one rotation is 2 pi radians divided by 5 seconds. That's it. That's the answer. Okay. So omega, the angular speed, is 2 pi divided by 5 seconds. All right. All right. Let's find you one that's a little bit less easy. Let's look at this one. A bicycle has wheels that are 28 inches in diameter. Diameter. Ooh. What's diameter? Diameter is all the way across. That whole thing is 28 inches. So what's the radius? The radius is 14 inches. This is one way that problems might try to trick you. They'll give you the diameter instead of the radius. Okay. A tachometer determines the wheels are rotating at, so this is, they're rotating at 180 revolutions per minute. Find the speed the bicycle is traveling down the road. Okay, so this is a little bit interesting to think about. The speed that the bicycle is traveling is actually the linear speed of the circumference of that bicycle. Think about why that is, right? How fast that wheel is hitting the ground, that's how fast the bicycle is moving. Okay, so really this is asking us, what is the velocity, the linear velocity? Okay, well, let's go back to our equations. And let's find them on here. We know that the velocity, the linear velocity, is the radius times the angular velocity. Okay. Well, we know the radius, so our linear velocity is 14 inches times 180 revolutions per minute. Okay, well, looks like we've got some work to do with units because this is a little bit of a mess, right? So let's think about this rotation. How can we fix this? What's one revolution is 2 pi radians per revolution. So those will cancel out. So that's good. So 14 inches times 360 pi radians per minute. Does that work for units? Inches per minute? I mean, it's not standard, but that is like distance per time, right? Let's transform this to, let's just practice our unit conversions. Let's transform this to miles per hour, okay? So let's see, in inches, there's 12 inches per foot, and there's 5,280 feet per mile. So that's cool. We can cancel the inches, feet. So now we're going to have 14 times 360 pi divided by 12 times 5280. So this is feet per minute. Probably better to have, this is miles per minute. Let's do miles per hour. So let's see, there's 60 minutes per hour. So our minutes cancel out. Okay, and I am cheating, in case you didn't know. I have the answer here. If this is about 15 miles per hour. Does that seem reasonable? Yeah, I believe a bike could go 15 miles per hour. Sure. All right, so a lot of this was just kind of unit conversions, right? The key here was realizing, okay, the velocity is radius times the angular speed. We know the radius because we were clever and didn't get tricked by the 28 diameter. And then we had revolutions per minute. We had to change the revolutions into angle, right? So we said, well, one revolution is 2 pi radians. So that gave us feet per minute or inches per minute. And then we used unit conversions to get something in an answer that made sense to us and some that we had a frame of reference for. Okay. So really, finding the angular speed isn't too hard. We saw that. If they give us, we just have to remember that 1 revolution is 2 pi radians. Okay. And then the other key equation to remember is this, that the linear velocity is the radius times the angular speed. Okay.